Hey guys, today we're going to solve the DP problem of Geek for Geeks. It's actually an easy problem. It's not a medium. So count ways to enter the stair. Here order does not matter here. Before that, we have uh, before writing the code, the important task is to understand the statement in clear and in an efficient way. There are n stairs and a person standing at a bottom wants to reach the top. The person can climb either one stair or two stairs at a time. Count the number of ways the person can reach the top. Order does not matter means here in order to reach the four stairs, you can either go 1 to 1 or 2 1 2 or 1 1 2. We have to consider all these types into one way. Okay, so that's the meaning of order does not important. So let us try to understand this. So we have n states. We don't know how many states we have. N states. We are exactly here, and we just want to know how many ways can I go to the top. One way, I just have to move on every step to reach the top, and another way, I can either cover two steps in one step like this. Yes, and this is another way. And another, is there any? Yes, there is. We can move one step in one step and two steps in next step, and then one step in again, like 1 to 1. So this is another possible way. And yes, there aren't any possible ways are available here. Yes, we can like one step, and finally two steps. Or this is have the same order like 1 1 2. So it have the same like 1 to 1. So both are same number of steps and in same way, but they are changing in order. So 1 1 2 and 1 to 1. Okay, but this problem has like order does not matter here. So we just have to count all these as one. Okay, in DP problem, we just have to understand. For me, we just have to understand how many steps we have to move in uh, like it's important to know how many steps we are moving in when there is no zero, when there is no step. Like if there is no stairs, yes, there is no there is, I mean, it is not possible to move to lift our leg and put it on the step because there is no step. So when n is equal to 0, the possible ways are also 0. But when n is equal to 1, so as there is a step, so we can have only one way. Just have to uh, like we just have to use only one step. I mean one possible move to move this n is equal to one step. If n is equal to 2, I mean count when n is equal to 0, there are 0 ways, and when is equal to 1, there are only one way. And when there are two steps, so how many possible ways? 1 1. So one possible way is we have to move on every step. So, and another possibility, we just have to jump directly and move to the end step when n is equal to two steps. Yeah. Okay, so for two, we have how two ways, right? So for three, uh, 1 2 3, and 1 2, and yes, is here three also having in two ways, right? We can change 1 2, but here order does not matter here, right? So, and when n is equal to 4, so he say, I'm already drawn the diagram for n is equal to 4 steps. So, and we get the result as 3, right? So, for 4 steps, we have 3. 3, as not true, it is 3. So, and after drawing some possible answers for initial test cases, it's better to look them carefully and find out the pattern. Here, here we have it zero counts for zero states, and one count for one state, two count for two states, and two counts for three states, and three count for four states. Here, two and two are even. So for even, whenever I get an even number, I just have to add the answer of the previous even number plus one, right? Previous even number plus one. If I get six states, I just have to add the answer of four states plus one. So the answer of six states is only four, right? So like we can test it. We can test the possible ways number of total count for four. I mean n is equal to six states. So one, two, and three, and four, and five, and six, and two, plus six. And yes, initial way I have to move on every step to reach the top of the step. And second way, so two and two and two. Okay, two steps. And third possible way is like um, one, one, two, two. That is the third possible way. We have three possible ways, and the fourth possible way is like what the possible ways like one, 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 and then one, 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 and one, one, two, two, and we have two, 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 and we can get one, 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 two. Understand? So one, 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 two. So fine. We have four ways for n is equal to six days. Yeah? This is how the intuition actually works in DP. You have to understand the how many ways are uh, for n is equal to uh, like minimum value of n is equal to 0. We just have to understand first how many counts are possible for when n is minimum, and then we can increment n value. We surely get what is exactly count for incremented n value, right? So when n is equal to odd, the same case which follows the even, we just have to add the previous odd answer along with plus 1 to the current odd element. So this is intuition. Now we're going to code it. So we have to take a DP. Now we do DP and plus 1, and we initialized our DP with 0 with 0, and initialized 1, DP of 1 with 1, and DP of 2 with 2, and from 3 we have to put the element in DP which is equal to the second element along with plus 1, right? And then we start to return area of an answer 3 to 1 plus 3. Oh, this is always works for DP problems. We just have to know what are the initial answers for the initial minimum values of n, and then you just have to find the pattern in order to know when n value is incremented. So this is all, and thank you guys for listening.